Hello and welcome to the Bulletalks podcast, where we explore anything and everything related to STEM. Think about this: every time you turn on a light, watch a reel, order food, or even fill a bottle of water, you are part of a system that uses energy, land, and raw materials. For most of history, how much we were taking from nature or what we were putting back into it was not important for us to consider. But today, we have reached a breaking point where we have to conserve resources, not just for the planet's sake, but for our own as well. That's where the idea of sustainability comes in. At its core, sustainability is about creating a system of resource use that never runs out, never collapses, and doesn't poison the environment we depend upon. It's about making sure that the choices we make today don't destroy the choices that everyone else has tomorrow. The exciting part is that scientists, engineers, and innovators are not just telling us to use less, they are reinventing the way that we produce energy, grow food, and even move around. They're asking, what if energy could be clean and endless? What if resource production didn't steal but actually gave back to the environment? One big area of this transformation is what people are calling the hydrogen economy. The basic idea is to use hydrogen, the most abundant element in the universe, as a primary energy source. Hydrogen is produced in several different ways, but right now, the most common is what's called grey hydrogen. That involves using steam reformation and natural gas, which unfortunately releases some greenhouse gases. A much cleaner version is called green hydrogen, which is made by splitting water into hydrogen and oxygen using electricity from renewable sources like solar or wind power through the power of electrolysis. If you've ever seen someone use a battery to separate water into bubbles of hydrogen and oxygen, that's just electrolysis on a smaller scale. The promise of hydrogen is huge. Fuel cells, which combine hydrogen and oxygen to produce electricity, can be used in cars to replace all petrol engines, giving us vehicles that only emit water vapor instead of toxic carbon monoxide gas. Hydrogen can also act as a seasonal store of energy, kept as liquid or gaseous hydrogen, and is primed for energy production. Imagine solar panels generating more power than we need on a sunny summer, and that extra energy being stored as hydrogen to be used in the winter when demand is higher. That could reduce our reliance on coal power plants and create cleaner national grids. But, as always, there are some challenges. Producing hydrogen is still much more expensive than fossil fuels. Every time hydrogen is converted, from production to storage to transport and finally to use, energy is lost. That means more hydrogen has to be made in the first place, reducing the overall efficiency of the system. Another issue is that markets can't always tell whether the hydrogen being sold was made cleanly from renewables or from fossil fuels. This makes it hard to discern that we're truly cutting emissions, or if certain producers are simply just cutting costs and running a scam. Some countries are developing hydrogen certification systems to guarantee that the hydrogen you buy is actually green. And while there's been progress, the infrastructure, like hydrogen pipelines and car refueling stations, is still very limited. Despite all of this, many high tech countries are investing heavily in hydrogen, seeing it as a way to clean up national grids, stabilize energy systems, and reduce reliance on coal, all in the process. Now, let's shift from energy to how we grow our food. Traditional farming, as productive as it is, often damages the environment. Using the same soil year after year without any care causes soil degradation, meaning the soil becomes less fertile over time and loses its nutrients. Add to that the heavy use of chemical fertilizers, pesticides, and herbicides, and you get soil erosion, water pollution, and a great loss of biodiversity, all of which are harmful to the environment. Fossil fuel Fossil fuel based machinery only adds to the problem. Clearly, farming as we know it has a sustainability issue. This is where bioengineering technologies come in. The idea is to use biology and genetics to reduce environmental harm and conserve resources. One approach is something called bioremediation, the use of living organisms like special types of microorganisms to clean up pollution. These microorganisms can break down harmful materials in soil and water, removing toxins and even restoring ecosystems. Another promising area is genetic modification of crops and animals. Using tools like CRISPR or CRISPR, which is a precise method for editing genes, scientists can make plants more resilient to harsh weather, require fewer resources like water or fertilizers, and even resist pests without needing any harmful chemicals. Imagine crops that don't wilt in droughts, or livestock that can thrive with less feed. These advances could feed growing populations while putting less strain on our planet. Of course, debates continue about the ethics and risks of genetically modified agriculture, but the technology holds real potential for creating more sustainable agriculture, when used responsibly, of course. Finally, let's talk about something closer to everyday life: transportation, and specifically electric vehicles. EVs have gone from being niche and futuristic in our minds to become mainstream in just a couple of decades. At their core, they are powered by rechargeable lithium ion batteries, the same type of technology that powers your phone, just on a much larger scale. Compared to gasoline powered cars, EVs produce much fewer carbon emissions, especially as more electricity comes from renewable sources. The Union of Concerned Scientists has reported even with today's energy mix, EVs typically produce half the emissions of traditional gasoline vehicles over their lifetime. And when charged with greener electricity, that number drops even further. EVs also have some cool features like regenerative braking, which means that when you hit the brakes, the car captures some of that energy and stores it back in the battery. That's like your car recharging itself a little every time you slow down. Isn't that amazing? Maintenance costs are also lower since EVs don't need oil changes or complex engine repairs, and the cost of charging an EV is often cheaper than filling up with petrol. Governments around the world are encouraging this shift with rebates, subsidies, and tax incentives for EV owners, as well as funding the construction of charging stations across the world. But as all technology, EVs aren't perfect. They still face high initial costs, and charging networks aren't as widespread as they need to be. The batteries themselves pose significant challenges as well. Recycling lithium ion batteries is pretty difficult, but researchers are working on safe and efficient ways to give them a sort of second life, like using old car batteries to store renewable energies for homes. As technology improves, EVs are expected to become even more affordable, practical, and sustainable. So, when we think about the future of sustainability, it isn't about giving things up, it's about upgrading. Hydrogen shows us how energy can be stored and used cleanly. Bioengineering promises a world where farms can give back as much as they take. And electric vehicles remind us that technology can make everyday life healthier and easier for everyone. Sustainability, at its heart, isn't just an environmental goal, it's a design challenge. And it's one that's already shaping the world that you and I are growing into.